सर वो गैप था ना बीच में।
अच्छा, और अच्छा, हाँ तुम लोग टायर्ड भी बहुत ज्यादा हो रहे हो करण।
सर वो लंच करते हैं ना तो
अच्छा, सुबह कितने बजे उठते हो? सुबह उठते हो क्या?
सर वो सुबह सोने जाता है।
मैं वही वही पूछ रहा हूँ कि सुबह उठते हो या नहीं उठते हो, मतलब कभी सुबह देखते हो? करम चुप कर गया।
कोई म्यूट कर दे रहा है, मैं नहीं कर रहा।
ओह ना, तो रिकॉर्डिंग, यू आर रिकॉर्डिंग। ओके, एनीवे चलो।
सर एक रिक्वेस्ट है, कैन यू मेक हम लोग को क्या आप अटेंडी बना सकते हैं? कभी कभी कोई म्यूट कर देता है, कोई निकाल देता है, क्लास से किक कर देता है, इसीलिए।
कोई निकाल देता है मतलब?
मीटिंग से निकाल
मतलब
देते हैं।
मीटिंग से अभी सब लोग प्रेजेंटर है ना, तो कोई भी किसी को ऐसे ही किक कर देता है मीटिंग से, इसीलिए।
इज इट पॉसिबल?
यस
यस
सर,
सर।
राइट नाउ आई कैन किक यू आउट ऑफ द मीटिंग।
आइस बस कर दो, और क्या?
मतलब
नहीं
अभी
सर,
अगर
वो
आपको कोई किक
करना
किया
नहीं
तो
है।
वो ऐसा नहीं
आप
होगा।
आपको मैं बोल रहा हूँ कि आप सेटिंग चेंज करके अगर हम लोग को प्रेजेंटर से हटा के अटेंडी बना देंगे तो फिर हम लोग नहीं
अच्छा
कर
जरा
सकते।
मैं देखता हूँ कैसे मीटिंग ऑप्शन।
पार्टिसिपेंट के ऊपर ऑप्शन होगा।
कहाँ पे?
पार्टिसिपेंट के ऊपर एक ऑप्शन होगा, पार्टिसिपेंट लिस्ट नाम
Callers
से
lead
लिखा
the
है।
callers, bypass the lobby. Anyone who callers join early. Everyone who can present. अच्छा,
बोल के, हाँ
in
बस।
my organization and guests only me. अच्छा, allow mic for attendee. Allow camera for attendees. Record automatically. Allow reaction. Okay, save हो गया। देखो तो अभी सेव कर दिया मैंने।
हाँ
यस।
सर, अभी हम लोग अटेंड किए।
हाँ,
हो गया सर, अभी हो गया।
ओके गुड, वेरी गुड। ऐसा ऐसा होता है, दैट्स गुड। अच्छा चलो फिर, लेट मी स्टार्ट। स्टॉप रिकॉर्डिंग। ओके, स्टॉप स्टार्ट। अच्छा, इज द स्क्रीन विजिबल फॉर फ्रॉम माय व्हाइट बोर्ड?
यस सर।
Okay.
Yes, sir.
So just let me take two small example. Suppose there are two matrix. कोई भी मैट्रिक्स ले लो। And 5 6 2 3 2 0 1 1, कोई भी 3x3 मैट्रिक्स ले लो। अब हमको निकालना है सो मल्टीप्लीकेशन ऑफ दिस टू मैट्रिक्स। ठीक है, so if I multiply these two matrix, what will be the size of the matrix?
So 3/3.
Again it will be 3x3. And what is the approach? Approach is the
Sir,
first element will be created.
So
First
all
row
the
into first column.
first rows all the elements, first columns all the elements sum.
देखो इरम्मा में तो
हाँ sir.
Yes.
this is the first element हो जाएगा।
हाँ.
Then if you go for second element, this second element, what I will do, I will take this one and this one.
Yes sir.
Then if I go this one and this one. Similarly for the second element, I have to go for this and the second row, second column. Okay. So you see, in this way I can create each of the element of the resultant matrix. This is the approach for creating the resultant matrix of the multiplication of two matrices. Now if I say that to find the element, one element of the resultant matrix, I need t amount of time.
So 90 for the entire matrix.
We requires 90 for the total computation. If I assume that it takes t amount of time, for one element computation, so I will require 90 amount of time to compute the entire resultant matrix.
Yes, sir.
Why? Because I am computing this entire matrix one at a time. First I am calculating this element, then maybe this element, then this element, then this, then this, then this, then this, then this, then this. So I am doing all the tasks sequentially. I'm doing the entire task sequentially, one at a time. So that's why I require 90 amount of time. Now think in a different directions. Instead of that, if I assume that I have 9 students, in my class I have 9 students, and I give one student, each one of you, the responsibility of computing one element. Student 1, the first student will compute the first element, the second student will compute the second element, third student will compute the third element, fourth, fifth, sixth, seventh, eighth, ninth. So I have 9 students, I pick up 9 students from you, your batch, and I assign each one of you to compute one element of the resultant matrix. And the interesting fact is that here computing one element is no way concerned with computing the other element. So this can be computed without the computation of this element, or this element can be computed without the computation of this element. That means computation each of these resultant matrix element is independent with each other. So if I assume that I have 9 students and each one of you is responsible for computing one element of the resultant matrix, then how much time should I take?
T, sir.
T. Sir. So what I did, I have taken a bigger problem of computing this whole matrix. This is my big problem. I try to find out the part of the bigger problem which can be computed concurrently. That means which are the part of the thing which are not dependent with each other. So I divided the bigger task to a small task which can be concurrently executed, and each of these tasks is being assigned to someone of you to compute concurrently. Is the idea clear?
Yes, sir.
Yes, sir.
So in the same way, you think that you have been given to write a program, maybe in any language, C, Python, Java, whatever programming language you use, you have been given to write a code for multiplication, finding the multiplication of two matrices. There are two matrices A and B, and you have been given to compute the resultant of multiplication of these two matrices A and B. So what you normally write the program, you will be writing the program inside the two for loop. This is a very standard technique. Inside the two for loop, you will be computing each element and will be printing. So you see, the entire task will be done in a sequential order. Each element will be treated separately. Each element will be treated one at a time. The other approach can be, you can divide this entire task to a small subtasks. And can assign. Hello. Orindam.
আমি ট্রাফের রাস্তাটা এরকম এবার থেকে একদিক ঠিক করবো আরেক দিক ছেড়ে দিচ্ছেন দাঁড়া বাবু মাকে
এই কেউ তো দায়িত্ব নেবে অরিন্দমকে ফোন করে বলা।
Sir, you are the presenter. You can mute him.
প্রেজেন্টার আমি বললাম, প্রেজেন্টার তো বন্ধ করলাম আমি। আরে
Sir,
অডিও
no,
ইজ
you can mute him.
Sir, you can forcefully
You
mute him.
can
how can I do that?
सर उसके वो आइकन के नीचे ऐसे तीन डॉट आ रहा होगा, उसमें म्यूट का ऑप्शन आता है।
এডিট করিনি
Why?
আপনি কি ফুটা উঠছে রে কথা মানে এখানে ফটো দেবো দেখি
Hello.
দেখি
Yes, sir.
I cannot mute.
सर उसका जो नाम साइड में दिखाता है ना अटेंडेंस लिस्ट में, उसमें हवर करेंगे तो साइड
अटेंडेंस लिस्ट में सब सेलिब्रेट है अटेंडेंस। ओके, remove from meeting। দেখো তো, হ্যাঁ মনে হয়েছে। So so normally we are habituated with writing the code in a sequential order.
Sir, you're not presenting your screen.
Disturbance দেখো মুশকিল চলি দেখো তো।
Yes, sir.
Yes, sir. Now it's visible.
Okay, so normally if this task is given to you that you write a code, whatever programming language you have, for multiplication of two matrices, then what you will do, you will be writing normally for two for loop, and you will be computing one element at a time. The other approach could be you can divide this task to number of subtasks, and you can create some of the child process. You can create number of child process. So for this particular problem, you have 3 by 3 matrix here, 3 by 3 matrix here. You have to compute the resultant matrix. What you can do from your main program, you can create 9 child process. One child, second child, third child, fourth child, fifth child, sixth child, ninth child. And one child will be responsible for computing first element of the resultant matrix. This one will be responsible for computing the second element. Third one will be responsible for computing the third element. Like this way, the ninth element will be completed, will be computed, and all will be done sequentially. Sequentially in the sense that as computing the first element is no way dependent on computing the second element. That means no output is taken from the first element to compute the second element, or computing the second element is no way concerned to take input from the first or second element. So computing each of these elements is independent on each other, and you can compute simultaneously. So what you can do, you can create 9 child process, 9 children of the main process. So you can create the fork system call, you can create child process, and each child process is responsible for computing one element at a time. Is the idea clear?
Yes, sir.
Sir, one question, sir. Sir, you said at the beginning, sir, that we can compute like these 9 children processes. They can be computed sequentially, or can they be computed simultaneously, sir?
So depending, that's why that is the motivation of today's class. That is the motivation of today's class. If you go for sequential computation, as we are habituated with,
Yes, sir.
So it will take 90 amount of time. But if we
No, I'm talking about the children, sir. I'm talking about the after forking, sir.
after forking, that means you are creating 9 children,
Yes, sir.
and each one of these children is responsible for computing one element. Just
Yes, sir.
like I have 9 students and I am assigning each student to compute one element.
Yes, sir.
The same way, see, computer runs with a very much close in the perspective of human society.
Sir,
Very
is
much.
the time taken to create 9 child processes, is it very negligible, very small?
Yes, that I will be discussing. I'll be discussing the overhead of it. Yes, very good question. How much time? Not only how much time, rather the memory it requires. Because the moment you are creating one child, number of child processes, your memory, that processes will also be loaded in the main memory. So memory can be one of the another issue, of course, that you are telling.
Yes, sir.
Okay, that I will be discussing, sure. So far we are discussing about the computation perspective. Now what will be the overhead and all, that I will be coming. Okay. So one approach is creating 9 children, and each children is responsible for computing one element and that's why you can allow these 9 children to execute concurrently. As a result, my computation time will be degraded a lot. The other approach, so one is child process, the other approach is called thread. Creating thread. So thread is very similar with process, but there is a difference between the process and the thread. Okay, but so far the concept is, the parallelism is concerned, both are creating child process and creating thread are same. But now come to the point of creating the children or creating the thread overhead.
Sir, what is a thread basically, sir? Like,
বলছি দেখো তো আমার স্ক্রিনটা দেখা যাচ্ছে কিনা আবার একটু।
Yes, sir.
Closely see this slide. Whatever program we write, normally the program is a single threaded process. Single threaded in the sense, if you write a program, that program will write in a single thread. That means one sequential computation. One sequential computation. If you have to bring the parallelism in the process, then you can create. So first you have to divide the entire task to number of subtasks which can be computed concurrently. Then you can go for multi-threaded or multi-process creation, multiple child process creation. Otherwise, normally it will be executed in a single thread. So, so for now you can write a program for multiplication of two matrices. Okay, and as I told that what procedure will you follow? You will follow the for loop, two for loop. Inside the two for loop, you will be multiplying and adding the elements, and you will be computing one element at a time. So the bigger for loop will run 9 times if you have a 3 by 3 matrix. So 3 by 3 matrix means multiplication will be 9 element. So for 9 element, the outer loop will be running for 9 times. So this program is a single threaded program. Only one thread will be executed. So your process will have a code section, the code, the instruction, your data section, input output files that you are using for executing that particular program or process, registers, values, and stack. From that process, if you create number of child process, so each child process will have the same thing, repetition. Each child process will have the same portion as repetition. On the other hand, from the same program, if you create multiple thread, instead of multiple child process, if you create multiple thread, the code section, data section, and file section will be common. It will be common. What will be the difference? For each single thread, there will be register and stack. Register, stack, register, and stack. So code section, data section, and file section, if you have, all will be common for all the threads running for a particular process. If you create multiple children, then multiple code section, data section, file section will be there. For that 3 by 3 matrix multiplication, if you create 9 thread, all the 9 thread will have the same code, same data, same files. Their computation registers value, registers and stack value, registers and stack value will be different. So this is one thread which is computing the first element, second thread computing the second element, third thread computing the third element, fourth thread computing the fourth element, fifth thread computing the etc. etc. So 9 thread. So you have the liberty to create 9 children, or you have the liberty to create 9 thread. If you create 9 children, so 9 times the code section, data section, and file section will be replicated. On the other hand, if you create 9 thread, so code section and data section, file section will be one. That will be used for all the 9 thread. Only the register and stack will be different for 9. বলো বুঝতে পারলে?
Yes, sir.
पपुड़ी समझ में आया?
Sir, that means all the processes which have children processes are also known as multi-threaded processes. Is the statement true?
No. No. If you create multiple, see, from the programming perspective, you should always prefer to go for multiple thread instead of multiple children. Because multiple children, if you go, of course you can do the job, the same job you can do, but for multiple process, if you create multiple children process, then it will be an overhead. It will be an overhead for your memory. Lot of memory space will be taken by 9 children. as well as context switching of the processes will be huge, context switching time, because you need to copy the entire code section, data section, and file section. Whereas for for multiple thread, the code section, data section, and file sections are same, so you don't need to copy. When you go for context switching of the thread, you don't need to copy or recopy the code, data, and files. Just the register value and stack value will be changed. So computation overhead is much less in multi-threaded instead of multiple processes. Follow.
Sir, then what is the difference between threads and child processes?
This is the difference that is the difference I told. The difference is from the computing point of view, both are same, but the overhead point of view, they are different. Why? If you create multiple thread, all the multiple thread of the same process will use the same code, same data, and same files. You don't need to replicate. So this portion will be common. This portion will be common.
So sir, if all the threads are using the same code, this means all the threads must have the same functionality.
No, not necessary. For of course, for this particular example, they have the same functionality. Karam, for this particular example, 3 by 3 matrix multiplication, all the 9 threads have the same functionalities. But in other case, it may not be.
Okay.
It may not be. But from the entire program, the code section is common.
Okay.
So all the threads are using the same code, maybe some part of the code. From the bigger code, a portion. Just দেখো তো এটা দেখা যাচ্ছে তো চেঞ্জ হলো এটা মোডটা
Yes.
Suppose you have a main program. This is one portion of the code. This is another portion of the code. Now the interesting thing is this part and this part are not dependent on each other. This part and this part are not dependent on each other. That means no output of this is used as the input of this. So the advantage is this part can be executed concurrently with this part. So you can assign this to one thread, this you assign to another thread. So both the thread T1 and T2 are using the same code section of the main program, same data section, same file section. Only the difference is registered value and stack. Register and stack. Whereas if you go for multi-processing, that means if you create this as a children, child 1, this as child 2. For this child 1, it will copy the entire program once again. This child 2 will copy the entire program once again. So code section will be copied, data section will be copied, file section will be copied, and of course the register and stack sections are there. So you see, from the memory usage perspective, creating the child process is much heavier than of creating a thread. And from this, we can also bring an analogy that if you go for context switching, so context switching overhead of course will be higher in case of child processes rather than thread.
Sir? Sir, but the main motive of creating a child process is to compute a subpart of the main process, no, sir? Then in that case,
to execute faster.
In that case, why is it copying the complete code once again? It only has to copy the subpart, which is...
Yes. So that is a disadvantage for child process. That is a disadvantage for child process. If you go for creating child process, it will be copied. Then it's better you go for threading. So that's why it is always wise for a programmer perspective to create or to write a program in a multiple thread. That will give you faster response. It will be responsive program. Your process or your system will be more responsive. One more example I can give you. For example, we all use HTTP and all for just you write Google www.google.com. So there must be some kind of Google server somewhere. Okay, and that is basically a server process. So in Google server, there is a server process running that is giving you this particular service, google.com. When you write google.com in your browser, it immediately opens the Google this screen. The server process is running in the Google server. When you are requesting, a thread is created who is giving your service. So in this way, if there are 100 people requesting for Google to open its home page, it will create 100 thread, not 100 process, because creating 100 process is a costlier affair than of creating 100 thread. So it is always wise to create thread for each of these requests.
Sir, in a thread, sir, we are not duplicating the code data files portions.
Right.
Sir, but my question is that how is the program keeping it common? Like, is it not? Is it referring to the main block of the code and data?
I'm not getting.
Sir, in case of children, sir, subprocesses have essentially the same code data file as well as registers, stacks, all that. It's basically identical program, just smaller in size. In case of children, but in case of thread, sir, we have a common code data file, right?
Right.
So we are referring to the original program's code data files.
Yes.
And sir, about the register and stack, sir, like what functionality are we getting from making identical?
So before that, you let me tell me that what are the content in the register and stack? Register and stack ki thake ki during computation?
Sir,
you have the answer. You can give the answer. I mean, the question that you are asking, you have the answer already.
Sir, data intermediate values, variables,
Exactly,
number.
intermediate value or intermediate results.
Yes, sir.
Intermediate results, and of course the accumulator, then is a program counter and all. Okay.
Acha,
So this data will be different from one thread to another thread.
acha. Got it, sir.
The remaining portion like code section, data section, file section will be same for all the thread running from the same process. So that's why the memory overhead is very, very less from the memory usage perspective. And of course, the moment you say memory usage perspective, the second thing will be coming, that is context switching perspective. For context switching of a process, you need to copy the huge amount of data. Whereas for thread, that code section, data section, file section, you don't need to copy, swap in and swap out.
Yes, sir.
That's why that memory overhead will be less. So that's why it is always wise to create multiple thread instead of multiple children process. And that's why thread is called lightweight process. The definition of thread is called lightweight process. But if it is asked in any exam or any viva, what is thread? Don't say just with a 3-word that thread is a lightweight process. It is not the lightweight in the sense weight. Why it is lightweight? That you tell. Follow? What is the definition then? I mean, what should be the? I mean, how do you define thread? Or what is the difference between thread and a process, child process?
Rate of execution of a process.
Then,
Sir, like what is the difference between thread and a child?
Child process.
Child processor. In case of a thread, we have a common code data file block, while in case of a child, we have a separate code data file blocks. In case of children, sir, mini programs are basically identical programs, but with different.
So code section, data section, file section will be copied.
Yes, sir, copied.
That's why thread is called lightweight thread is a lightweight process. It is something like process, but much lighter in the sense, or I mean, the memory requirement, the computation overhead is much less than a process. So you can achieve for parallel computation, you can achieve by creating multiple processes as well as multiple thread. But always from the programmer perspective, you should always prefer to go for multiple thread. ঠিক আছে?
Yes, sir.
দেখো তো দেখা যাচ্ছে কিনা আমার স্লাইড দেখা যাচ্ছে?
Yes, sir.
Okay. So you have so by default, any program you are writing, or so far the program you are writing in your first semester, second semester, or third semester, fourth semester, all the program by default is a single threaded process. By default, it is a single threaded process. So you have to make it multiple thread to get faster response from the system, to achieve parallel computation. So what is the benefit of creating multiple thread? Responsive. To get faster response from the system. You have a large program, and that program may have multiple subtasks which can be executed concurrently. So you can create multiple thread for each of these subtasks. Resource sharing. The code section, data section, file section are common for all the thread. So all are sharing the common resource. economy, your memory requirement is much less. Your Google server, I mean any example you can take, any web server. You can have any web server. The moment a request is coming, it will create a thread for each of the service. So if there are n number of requests are coming, so for each of these, it will be a thread. For example, we can take several examples like this. IRCTC. All you are familiar with booking a ticket from IRCTC, right? So parallelly, many people are booking their ticket from the same website. IRCTC is a server which provides you some kind of database services. Okay, so server means nothing but it is a process. It is a server process which is running in one end, and you are getting the service from it. So for that, you are requesting from your terminal to that server process that I need this service. I need the ticket from Durgapur to New Delhi with Rajdhani Express. So that is my request. I am requesting to see the ticket from where? IRCTC server. So IRCTC server is a process. Now, the moment my request is going to IRCTC server, it will create a thread for me. Immediately, maybe Projato is requesting also for another service to the IRCTC. So another thread will be created. At the same time, some another person, maybe Khitis, is also requesting for one ticket from maybe Bilaspur to Bombay. Somebody is requesting from Bombay to Chennai. So for each of these requests, IRCTC server will create a separate thread. Each thread is responsible for serving one user, or user 1, user 3. So each of the thread is serving one user. Each of the thread is serving one user. So the moment that user close is computation is done, that particular thread will be killed. Only that thread will be killed, not the entire service or entire server process. Because server, again, I am telling you, server is a process. So the server process will not be killed, because that same server process is serving another 99 user. So only one user left the job, left its computation. So that particular thread will be killed. The remaining 99 thread will still be running. Okay. Utilization of MP architecture. Can anybody say what is this?
The multiprocessing.
Multiprocessor architecture. Multiprocessor architecture. So today, if you go for purchasing a laptop or desktop, whatever, the minimum is dual core or quad core processor. That means in a single CPU or single processing unit, you have 4 core. CPU 1, CPU 2, CPU 3, CPU 4. So there are 4 core. Okay, let me come to this point. So you purchase a laptop which is having 4 core. CPU 1, CPU 2, CPU 3, CPU 4. As I told you, by default, your program is a single threaded program. So far we are habituated to write a program is a single threaded program. So if you write your 3 by 3 matrix multiplication you will be writing in a single program with a single thread. That means one thread of execution. So you may have a laptop which can support 4 core. Listen very carefully. You have a laptop which is having 4 core. But you are writing a program of matrix multiplication which is having only one thread. Okay, you are writing a program which is only having one thread. So out of this 4 core, one of the core will be used. The remaining core will not be used. They will be kept idle. So that's why you may have multiprocessor architecture, but as you have not written your program in a multi-threaded architecture, so only one of the processor will be used, the remaining processor will be kept as it is. So this is called underutilization of your system. Underutilization of your system. But instead of this, if you write your program with a multiple thread, depending on the parallel task that you can do from your execution. So maybe there can be 9 thread, for example, or earlier example. So 9 thread can be scheduled. This 9 thread can be scheduled in this 4 core in a multiplexing time manner, 4 at a time. So that will give you a huge parallelism in your computing. Bolo. Is this idea clear?
Sir, is there a limit for how many threads we can create for
Yes.
each CPU?
Yes. Yes. I will come to that point. So is this idea clear?
Yes, sir.
Sir, and here responsiveness in the sense, is it only in terms of time taken or anything else also?
Yes. Responsive means time. I asked the questions, how much time you people take to respond? There are 180 students, but none of you respond, or you respond after maybe 5 minutes. But the moment I asked you a question, some of you immediately raised your hand. So that means my students are very responsive to this particular class. Okay, and I, of course, as a teacher, I will be looking for a responsive student. That is my objective. I will always look for some responsive student. The student who will always interact with me. The student who will always try to interact in the class. So that will be my objective as a teacher. In the same way, as a user of the computer system, you are always looking for a faster system. Faster system in the sense, faster response. You submit a task and you want that your task should be executed as fast as possible. Any doubt up to দেখো বলো কি বিশ্বজিৎ ঘোষ কিছু কোশ্চেন আছে?
No, sir.
No sir, সব বুঝে যাচ্ছ? Now you can create number of thread, of course, depending on the program you have. But the question is, whether your hardware architecture is capable enough to handle this. There is a limitation of your hardware as well. From programming perspective, you can create number of thread, but how many thread your system can handle, your hardware, your processor can handle. Of course, if you have a 4 CPU, 4 core can be supported. But is it that only? Now, there are two types of thread. One is called the user thread. Another is called kernel thread. User thread managed by the user level. That means as a programmer, when you are writing the code, you are creating multiple thread. So depending on the program you have, depending on the algorithm you have, depending on the data input you have, you can create multiple thread in the programming perspective. This is called user thread. Some of the user threads are POSIX thread, Win932 threads, Java threads. So there are different libraries and system calls that you can use for writing your code. Some of you, of course, it will be shown in the lab. There is another thread called kernel level thread, supported by the kernel, the core of the operating system. As I told in the first class, that a portion of the operating system or some program of the operating system are always in the main memory. Some portion of the operating system are always running in the main memory. That is called the kernel. So this is called kernel level thread. So the threads that are managed by the operating system kernel is called kernel level thread. Some of the example of this. Now, what is the relationship between user level thread and the kernel level thread? You can map many user level thread to one kernel thread. So many to one. It can be one to one or many to many. Many user level threads map to a single kernel thread. There are some examples. So how does it work? You can create, as per your requirement, you can create a number of user thread. In your program, you can create a number of user thread. And all the thread in the user level are mapped to a single kernel thread. That is this. All are mapped to a single kernel thread. So operating system, either it may support number of thread, but you are mapping all this thread that you are creating in your program to a single kernel thread. So if you go for this structure, the disadvantage is if somehow one of the thread is blocked due to some input output or something.
Sir, sir, sorry to interrupt, sir, but we have a practical class now, sir.
Oh, wow.
Yes, sir. Embedded system.
কি ক্লাস আছে?
Sir, embedded system design.
ঠিক আছে, ঠিক আছে। আচ্ছা, অভিষেককে বলো, অভিষেক আছো নাকি? এই প্রজেক্ট অভিষেক তোমাদের সিআর তো নাকি?
হ্যাঁ স্যার।
একটু বলো তো আমার সঙ্গে কথা বলতে একবার পরে রাতের দিকে বা যখন হোক।
ঠিক আছে,
ঠিক আছে, মেসেজ করে দিও। ঠিক আছে, ওকে বাই। ওকে বাই দেন।
থ্যাংক ইউ স্যার।
থ্যাংক ইউ স্যার।
হ্যাঁ বলো।